All right, so good evening, everyone, and welcome to another edition of Virtual Starry Skies. I'm your host, Joe Aiken, the technical director of the Tung Visualization Lab and Planetarium. Tonight, we're actually going to be talking a little bit about comets and impacts. So, just a couple of things about comets before we get started. Some of the most beautiful objects in our universe, definitely in our solar system, but they can also pack a deadly punch. So we're going to try not to be too negative tonight, try to end on a happy note. Because in Earth's history, Earth has been hit by a lot. I mean, just take a look at the moon, see all the craters on the moon. Earth would actually have just as many craters, but we're going to talk about that in the second half of the show. First half, let's take a look at more of the nighttime sky here and uh, kind of notice a couple of things that you can see here. Take off the title. We set up the sky for mid-August because every year one of the brightest meteor showers to appear from Earth is visible in mid-August. So if you look up, you might see a couple of those shooting stars, or what we call meteors. Remember, a meteor or shooting star is not a star that's flying across sky or star falling. It is actually tiny dust grains, sometimes the size of grains of sand, burning up high up in the Earth's atmosphere, put there by a debris field left over from a comet. And so the Earth actually enters through that debris field. You'll get all these little particles kind of burning up in the atmosphere. So we see them as a flash of light going through the sky. Now, every now and then, you might get something a little bit bigger, something maybe the size of a softball come in, and it will light up the sky. This is what we call a bolide, something a little bit bigger than dust grain. Again, roughly softball size or bigger, and something like that would actually create a sonic boom. Have you ever seen something streak across the sky and maybe break up? That's most likely something a little bit bigger, a little bit heavier. This meteor shower is called the Perseids because it appears to originate from the constellation of Perseus. And it's actually just depends on where that debris field is coming from the sky, that radiant. And that's why we call different meteor showers by the names of different constellations. For instance, August is Perseids. If you go to November, you'll have the Leonid meteor shower and so forth. And actually, in July, we have one coming up, but it's kind of faint from our viewpoint. The Southern Hemisphere actually gets a little bit better view of the Ocarids, is what it's called, and that's from the constellation of Aquarius. Now, let's back away from the Earth, and we're going to turn off this meteor shower and take a look at what's causing, in fact, this meteor shower. So here we go. Now you're going to see a whole bunch of like little particles there. We got the Earth coming into view, that little dot with the Earth's orbit. You got the sun to your left. I'm just going to let this set up here just a bit. And as we zoom out, you'll see that kind of debris field. Now we've, of course, scaled it up so you could actually see it. If we were to set this in motion, this is something that you would actually see if we were to kind of move the Earth. We'll go backwards in time for a bit. And so there you can see the Earth. I'm just going to move this around just a bit so we can see this here. And so as the particles go and orbit around the sun, just like that comet, the Earth passes through that debris field, and that's where you get the meteor showers from. Now, of course, you might have sporadic. If you ever looked up in the normal sky, you might see one or two flashes of light, maybe even a dozen at times. Those are what we call sporadic. Those are just kind of debris flying around the sun. Now, let's go back in time just a bit. So what's causing this is actually a comet along that same orbit that you see that debris field. See how it kind of makes a nice elliptical orbit there. Now, at times, sometimes we talk about kind of big outburst of meteor showers. This one's going to be really big. That's actually usually more of one of those clumps of debris comes flying in and kind of replenishes or gets a little bit thicker, or the Earth enters through a thicker part of the cloud. So you get more debris hitting the Earth's atmosphere. All right, so this is very similar to, so comets behave like a very famous character. You've probably seen this person. Of course, I'm referring to the character of Pigpen from the Peanuts cartoon. So hopefully we won't be copyright. But so here's Pigpen as he flies around. He gets dust everywhere. He gets very dirty. He kind of gets everything dirty as he moves around. Very similar to comets. As they move through the solar system, they drop behind all this debris field. The particular comet that actually dropped this debris field is the comet Swift-Tuttle, named after the founders or the discoverers. Actually, Swift-Tuttle was actually named by or discovered by two different astronomers, both Lewis Swift and Horace Parnell Tuttle. Two different observations, rough in the same year. One on July 16th, 1862. The other one a couple of days later, again, 1862. This comet is what we call a short-range comet, which means it comes from a belt of debris called the Kuiper Belt. It takes about 133 years to orbit once around the sun. So the last time it came through was actually in the early 90s. So we got a nice replenish of meteors of the Perseids. And later that decade, late 90s, early 2000s, the Earth actually had a big outburst of Perseids and put on some spectacular shows. So we're going to have to wait for another 100 or so years for that to happen again. But it's still pretty bright because usually this comet actually has a little bit heavier material, a little bit denser material in the comet itself as it leaves behind. And so you get really bright meteors, some what we call fireballs. But let's take a look actually at the comet itself. We're just going to fade this down. We're going to bring up the comet. I'm going to talk a little bit about the structure of comets, and then we'll go into a little bit of historical fact and kind of what people used to think about comets in years past in our history. So here we have a comet. You can see that coma, which is the central region of the comet itself. And if we zoom in here, you can get a little bit closer to it. And it was a famous person by the name of David Levy, who has actually discovered lots and lots of comets, who said about comets, comets are like cats, or comets are cats. They have tails, and they do precisely what they want. And as you can see, our comet definitely has tails. In fact, you might see two tails. The big kind of grayish white tail is actually what we call the dust tail. It contains all that material, dusty material, kind of flying off the comet as it flies around the sun. The other one is actually what we call an ion tail. And an ion tail. And both these tails can stretch million miles behind the comet itself. Because you got to remember the central region there, that little white dot, and we can go a little bit closer here so we can see it. That little region is actually a small rock only about 16 miles or 16 kilometers in diameter. So it's very tiny compared to the rest of the comet itself. What's going on is the comets are made up mostly of water ice, as hard as rock, and a little bit of rock and other kind of simple compounds, if you will. So you can kind of barely see it there. You can see that kind of rock right in the middle. So what happens is, as it orbits the sun, once it hits about the orbit of Jupiter, it starts to heat up. And what happens is that water ice that's hard as rock heats up to the point where, of course, in space, we can't have liquid water. So we actually call it sublimation. And that's when it goes straight from a solid to a gas. And all that gas comes spewing out of the central region of what we call the nucleus here. And it creates jets throughout the rock itself. And as it flies around the sun, all that stuff goes behind it and leaves behind a tail. Now, the ion tail, so that's actually what the dust tail is made of. The ion tail is actually charged particles interacting with the sun's solar wind. And what that means, as the sun gives off charged particles, as it sends out high energy material flying off the sun every second, what we call the solar wind actually hits the charged particles flying off the comet and pushes them out. And so you can always tell where a comet is coming from by looking at the dust tail that's following behind it. The ion tail, you can always tell where the sun is because it's in direct opposite from the sun itself. So it's 180 degrees facing the other direction. And so here we go. If we zoom out here, you can actually see that come into play here. So our sun's going to be down and to the left there. We'll just kind of move around. There's our sun. And then you can see my mouse. There's that dust tail flying behind the comet. There's that ion tail kind of going in the opposite direction. So again, this comet goes around about every 133 years. Comets have highly elliptical orbits. If we kind of take a look here and keep zooming out, what we're going to do is going to get us set up here. I'm turning on a couple regions. One is the Kuiper Belt, where this comet actually came from. The other one is called the Oort cloud, which is a region of comets that spread out. If you heard my talk last week, we talked a little bit. We ended with the Oort cloud. That extends out to about 1 light year away from our sun's gravitational pull. So we're going to put this in motion. So it comes by the sun only for a couple months, and then it flies out. So this comet, again, 133 years to orbit once, goes all the way out to where the Kuiper Belt is. So we'll just tilt down so you can see that. These comets, again, have highly elliptical orbits, stays out there. We're traveling about 5 years a second right now, so you can actually see that flying by with the inner planets. And then it comes right in, and we're going to pause it right about here. And then we're going about 3 months a second right now. And so once you'll see the comet, we're going to scale it up. Once it hits Jupiter, starts heating up, grows that tail, which can stretch millions of miles away from the nucleus, and it goes flying around. And sometimes some comets actually have tails that will fan out. Sometimes they'll break apart. There's actually 2 comets happening right now. One is Comet Atlas. The other one is Swan. Atlas, on its way in, is actually tearing itself apart. It did survive. It actually made it around the sun, and it did survive. So some comets actually burn up into the sun. Some burn up before they even get there. Some will take a couple orbits and then burn up. So it depends on how loosely together everything is compacted and how many times it's been around our sun and what is picked up as it travels through our solar system. So again, comets, just kind of reiterate, they have tails. They're like cats. They kind of do what they want, meaning it's really hard to predict when comets come in. For instance, we thought Swan and Atlas were going to be our comet of the decade. You know, it's going to be the really bright comet. It didn't really do much. They flared for a bit. They got to where you could actually see it with a pair of binoculars and then broke apart and fizzled out. Sometimes they actually hold together and they flare again to be as bright where you can actually see it from with the unaided eye. And sometimes not. So they're really hard to predict. Another thing about comets, they're like pigpen, right? So whenever they move around the solar system, they leave all that dust and stuff behind, and then planets can enter that dust, and that's where you get meteor showers. And that happens over all the planets in our solar system. Now, sometimes comets will get, and we're going to talk about this in just a bit when I show some of the images, sometimes comets will get too close to a big planet, for instance, like Jupiter, and get ripped apart. That happened in 1994. We actually witnessed it with the Hubble Space Telescope. That was Comet Shoemaker-Levy 9. It flew past Jupiter, got ripped into 26 pieces. 1 year later, they all hit into Jupiter itself, causing these big black scars. Those pieces were only a few miles across. The scars that are left were bigger than the planet Earth. These comets are moving extremely fast. Now, when we look at them in the nighttime sky, they're not going to move a whole lot when they start to be visible. They're almost like planets. But in the grand scheme of things, they move really fast. But when you're looking at the nighttime sky, you can go out several nights, and pretty much in the same place you'll see it. But over periods of weeks, they'll begin to move against the backdrop of the stars. And then they move really fast when they're around the sun. And then when they're far away, they move much slower. Again, law of orbital dynamics there, thanks to Kepler and Newton for developing those laws. Okay. Now, speaking of Kepler and Newton, before their time, of course, comets, before the kind of scientific method, and we started actually observing these in more closely detail and found out that the comets are not bad omens. They were considered bad omens in our history, in human history. Some of the comets made throughout history the heavy hand of God, right? Another one, Emperor Vespasian said, "This hairy star does not portend evil to me." Uh, Interesting enough, later that year he fell ill and died. Again, really interesting things happen when comets come about. People kind of use their imagination. Uh, and in 1528, there was a comet described by a Frenchman physician. The comet was so horrible, so frightful, it produced such great terror that some died of fear, others fell sick. It appeared to be of string length and was the color of blood. You know, different comets can actually have different colors depending on what elements are actually kind of sublimating inside. And so sometimes you'll get green comets, sometimes blue, sometimes red. The Great Comet, around the time of Caesar's assassination, a couple months later, in fact, after he was assassinated in 44 BCE, there were Olympics that were games in honor of Caesar. This great comet appeared. And it turns out that it just so happens that it was in orbit. It went close to the Earth when Earth was, or closest around the sun when Earth was also in that same part of its orbit. And it was the brightest comet. Apparently, it appeared on record. You could see it in the daytime for weeks. And Caesar Augustus, who was becoming emperor at the time, dictated that this comet is, of course, a Caesar, right? Coming back and taking Caesar on to the Neverland, I guess, or off to the afterlife, kind of riding on that comet. So again, throughout history, comets have actually been seen as different kind of omens. And here's some of these images here. Let me bring these up here. I found some interesting artwork throughout history. Here's a cuneiform talking about a bad omen of a comet. The Aztecs saw comets during the Spanish conquest and invasion. Here's a Chinese woodcut showing several comets. Of course, one of the most famous events happened with Harold. If you recognize this tapestry, the Bayeux Tapestry, a comet was seen during after the King of England perished in 1066. Harold was promised the throne, as were a couple other people. He felt a little shaken in his boots of ill after seeing a comet, and of course he was defeated by William the Conqueror and lost his throne, of course. The Great Comet of like the 1500s and 1800s, there was a in 1680 known as the Great Comet of 1680, created fire and famine. Two comets appeared in 729. Here's a little quote. In the year of our Lord's incarnation, 729, two comets appeared about the sun, to the great terror of the beholders. One of them went before the rising sun in the morning. The other followed him when he sat at night. So one in the morning, one in the evening. As were presaging much destruction to the east and west. One was the forerunner of the day, the other at night, to signify the mortals were threatened with calamities at both times. They carried their flaming tails towards the north as it was ready to set the world on fire. At which time a dreadful plague of Saracens ravaged France and miserable slaughter. So this is actually by Beatty. It just so happens that comets actually appear. People kind of freak out by this during this time, and of course maybe create some of these famines themselves. But it is quite coincidence that many of these events happen at times of their comets. Napoleon actually used to think that comets were actually good luck, as did Caesar at the time. And of course, most recently, some of our 20th, like 19th century writers and 20th century writers, for instance, who can tell me the author who came in with Halley's Comet and then, of course, went out with Halley's? Very famous author. If you said Mark Twain, you are correct. And the quote is, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it. It will be the greatest appointment of my life if I don't go out with Halley's Comet. The Almighty has said, no doubt. Now here are these two unaccountable freaks. They came in together. They must go out together." And of course, Twain died in 1910 when Halley was actually visible again. So again, really interesting that some of these events take place around the comets. All right, so here's some of the images of comets over the last decade or so. Some of the right ones. This is Halley's Comet. Let me bring it back up here. So first off is Halley's Comet, seen in 1886. During that time, we actually were able to get a picture of the nucleus for the first time of a comet. And here's what that looks like. You can see those jets flying out of the nucleus. Of course, recently we're actually able to land on a comet. We're going to get to that. There's Shoemaker Levy 9 being split apart, called the String of Pearls, 26 different pieces, 1994. 1996, Comet Yakutaki had this beautiful, long, skinny tail. People who remember in the mid-90s, of course, remember Hale Bopp, of course, in the late 90s. Hale Bopp is one of the brightest comets we've seen in better part of a century. This was interesting. This is actually the comet of Akia Zhang, and we were actually detect movement in the tail. So as it interacted with that solar wind, it moved the tail and split it off 2 or 3 times and caused really interesting effects. This is Akia Zhang as well. Most recently in early 2000s, Comet McNaught fanned out its tail as it flew around the sun, became really bright. Unfortunately, here in the Northern Hemisphere, we could not actually see but just a tiny bit. Southern Hemisphere got a great spectacular view. The one that you just saw was Comet Sliding Spring, which made its way past Mars, very close to Mars. In fact, that the material from that comet interacted with Mars' thin atmosphere. And we actually, as our spacecraft were there to see that. We actually had to hide the spacecraft to go on the other side so they wouldn't be bombarded with radiation. These are some of the Comet Ison. Here is Comet Atlas, and you saw one of the images actually of its breaking apart. That was actually by the Hubble Space Telescope. And then, of course, the one before this is actually Comet Swan. So these are some of the comets that are actually happening right now. Swan is visible early in the morning sky, rising right before the sun. You got to know where to look. It's next to a bright star called Fomalhaut, and you actually need a pair of binoculars though to see it. So those are just some of the, more pretty pictures, more beautiful images of the comet, not really causing destruction, more putting on a show for our views. Now, like I said, we were able to actually land on a comet, and that was with the spacecraft called Rosetta. And Rosetta was a spacecraft launched 2014. And actually, here, I'm going to set this in motion because this next little kind of sequence might take a little bit long because we actually have it all programmed out so that it actually shows the orbits, and it will show the orbits. Thanks to actually Rainer Christensen from Flensburg Planetarium in Germany for helping out and producing this script. So as it comes in, you're going to see Comet 67P. They're spinning. What's interesting about this, whenever we approached, we noticed that there was actually 2 lobes. There you can see Rosetta. It's going to make several passes of Comet 67P as it goes along here. So you're going to see it kind of coming into view and out of view several times as it makes its final approach. What was interesting about Rosetta is that it actually had a small craft with it, a lander called Philae. And Philae actually contained a little landing pad, if you will, and it was actually able to get pretty close to the nucleus and try an attempt at landing. Now, as it came in, you can see the time going. The comet itself spun once around every couple of hours or so, so it was actually spinning really, really fast, which made it very difficult to plot a landing. And so as we get close, there's Rosetta. It's actually spinning around now. It's getting a little bit closer. It's got to slow down. It's making all those orbits not to waste fuel. But what the lander found out was the comet itself is only 16 miles across, very small, which means it has low gravity. There's also, of course, particles flying off this thing, right? Of course, we met it before it started sublimating, but there's still pieces kind of falling off as it spun and moved around the sun. It turned out to be quite difficult to land. And if all went well, we would have a nice soft landing. Of course, in reality, that never happens, right? And Philae actually bounced a couple of times, and we're going to show that in just a bit. So, okay, so here's Rosetta kind of making its final orbits, and a couple of images here. Sorry, my dog is barking in the background. I don't know if you can hear that. But so here's Rosetta making its final approach, and we're going to have it stop, and then we're going to zoom in a little bit closer onto the Philae lander, and we'll get a little bit closer to the comet itself. So as you can see, it made several passes just in a couple of months. Here we are, October 31st into November of 2014. And we're going to make it stop here just shortly. Now, this was actually a mission by the European Space Agency. All right, so on November 12th, 4 a.m., let's a little bit close. There you can see those two lobes. We're going to get a much closer look in just a second. All right, so there's an up-close look at the Rosetta with those big solar panels. Now, I had several cameras on the Rosetta spacecraft itself. One was a wide field camera, and then they also had the Osiris camera was able to take really nice close-up images. So there's the Philae lander heading off onto the nucleus of the comet 67P. You can see those the landing platforms kind of extended. Again, this was the very first attempt ever to actually land on a comet itself. Yeah, someone actually just commented about my dog. We actually have three, and one's inside. The other two are running around outside. So it's probably what he's barking at. But okay, I digress. So here's the lander. Let's follow it in now. And these are actually the real movements made by these spacecraft as it came in. Sorry, this is a little bit long, but I wanted to actually show all the little details here. And if all went well, it should have made a nice soft landing and gave us an up-close image of the surface itself. Of course, we know that did not do that at all. In fact, it actually bounced about 3 times before landing on the 4th bounce, almost falling off the comet itself. And we did lose contact after it landed, shortly after it bounced that last time. But then Rosetta actually got a nice up-close image, and I'm going to be showing those shortly. But really interesting things that we discovered as this comes down and lands. One is the 2 lobes, and there's actually fresh new material that's combining the two. And we think what happened that this comet might have broken apart, and then when it went around the sun, and then when it went back out into space in the cold, it kind of fused back together by clumps. And it really got us a good idea of how our early solar system might have formed with these planetesimals, matters being clumped together. And here we go. It's going to get a little bit closer here. It missed its original landing spot, and it came in at an angle, which caused it to bounce the first time, and then it kind of did some tumbles and rolls. So we're actually not going to show the tumbling here and the bounces, but we did get an image because, of course, during this whole time, Rosetta was taking pictures the whole time. So this just crossfade to it landing, what it's supposed to look like, and here it is actually on the surface itself. Now, the material on the surface, we thought it was probably, maybe hard ice and rock. It's a bunch of pebbles, and things move around very easily here on the comet, especially as it spins around. Boulders move, cliffs fall away and erode away very quickly, so it's not a nice stable place at all. And here's some of the close-up images by Rosetta using the OSIRIS-REx camera. Here you can see those pebbles the two lobes, again, this thing's only a few miles across. Think of central New York region here, or maybe even smaller than our central New York region. Here's another image, close up of these lobes. Next image I'm going to show that bounces. You'll see four of them, minutes or a few seconds apart. So there's the first bounce. It came up, bounced again, and then finally touched down somewhere in here. And you can kind of see some of the pixelated image there by Rosetta. But it turns out it actually tipped over into like a crevice. And we found it a few months later, trying to find it. We can see all those pebbles. So that's a very up close image. This is one of the flybys after it landed. And there you can see it kind of tipped over on the side. That's why we lost contact. The solar panel it lost energy. It was facing the wrong way, facing into the comet. So, and you can see it's on one of the top of the lobes there. That's this little red rectangle kind of blown up a couple of times there, so you can see it. Again, very, very lucky they actually did survive. At least it's still there on this comet. Probably not for long once the comet actually starts sublimating again as it goes around the sun. But you can see all that loose rubble. Again, here's another graphic that I want to put up, just talking about what we actually learned from this mission, other than sending a multi-million-dollar lander to crash to its doom. A lot of things we thought that comets were just kind of dirty snowballs, kind of dead worlds, old systems of our solar system, just kind of flying around, sublimating out, and eventually kind of evaporating or sublimating into the sun, if you will. That's not true at all. It's actually very complex geology happens. No liquid water whatsoever. Straight from solid to gas, of course. We thought maybe it might heat up enough and have some type of atmosphere that would create maybe some liquid water. That is not true at all. In fact, there's actually very complex carbons here. We found rich in carbon, carbon monoxide, oxygen, nitrogen, argon, suggesting that, you can see there it kind of probably formed at very, very low temperatures. So not in the inner solar system where things would have heated up and melted. These formed kind of further out. So the lighter material got pushed out and formed way out beyond the inner solar system, way out in the outer solar system. So these have been floating around for billions of years around our sun. So we know that they're not high density. They're not, almost like a planet. They are actually very light material, which we kind of knew, but this actually confirmed that. And they can break apart very easily. So we learned a lot from this mission. Another thing that was really cool that we found, I'm going to play a little video here. This was taken from the Philae lander that we actually covered. I'm going to let this play just a bit. What do you notice besides some of the static? That's snow. Material flies off the surface, rains back down as snow. Again, this is all solid, so as it sublimates off, it snows back onto the surface, creating a new surface in between those two lobes. First time we've ever recorded that from a comet. So these things, we've learned a lot about these comets. I'm just going to remove this here. We learned a lot about comets. We know that there are billions of objects. We've named over 3,000 comets in our Earth's history. Of course, Edmund Halley is the one that actually figured out that Halley's comet, his own comet, repeated on a cycle of 75 years. Other comets take anywhere from 50 to 200 years. So again, those are those short-range comets formed in the Kuiper Belt. Other comets like Hale-Bopp, which comes around every 2,500 years, give or take a few. Those actually originate out much further in the Oort cloud. Some take millions of years. We even had our two comets that came by in this past decade are interstellar comets. These are comets that did not originate from our solar system, but from other star systems and visited. One was kind of a weird oblong shape. Another one just came through not that long ago, just a couple of years ago, and had a huge high hyperbolic orbit, which sent it back out. So it just happened to be passing through. So that kind of gave rise to some inclination that other star systems, and we do share material as we go around our galaxy with other stars. Now, of course, all this debris flying around, sometimes the Earth gets in the way and we get impacted. So I just want to start off and show one of these impacts. If you recognize this, you should. It's in the United States, one of the youngest craters that we have here on the Earth. This is, of course, Meteor Crater in northern Arizona, just outside of Flagstaff, known as Barrington Crater, once known as Canyon Diablo. The crater itself is about a mile wide, or a mile in diameter, about 3/4 of a mile, I should say. Formed only 50,000 years ago by a rock the size of about 50 meters. So that's about 160 feet. Not very big at all. And so 50 meters, if you've been in our planetarium, our dome is about 10 meters across, so about 5 times the size of our dome. And so imagine, something that small hitting the Earth and causing a crater that's a mile wide. Pretty impactful. We think the meteorite actually struck at about 45,000 miles an hour when it hit. We think that most of it vaporized when it actually did impact the Earth. There's actually a small, what we call central peak region, which we find on most craters, a material that kind of bubbles up, that contains both the impactor and the impacted, if you will. Material kind of flies out around it in what we call almost like a splash pattern. And in some cases, the really big meteors, like for instance in Chicxulub, and we can go, let's see if we can fly around here to kind of take a look at that. We'll fly off the Earth. So Meteor Crater, you can actually see from space. You can see it right there, the little Meteor Crater. And there are, in fact, many craters here on the Earth, but we don't see too many of them. Usually in the deserts, but that's because we have a nice bit of water and wind, which erodes away many of our craters, so we don't see them. Otherwise, we look a lot like the moon. Remember, the moon is filled with craters. The Earth gets hit just as much as the moon. In fact, over the last decade, or 2 decades, I should say, here are some of these recent events. So it's going to take just a little bit to load. I'm going to show a couple of things kind of flashing in. First off, here's a crater that we think hit the Chesapeake Bay area that's actually underneath the Chesapeake Bay. You can see how big it is. This thing is actually very, very massive. Again, a rock a little bit bigger than the one that hit Meteor Crater caused that crater. So you can see the scale there. When meteors impact, again, this is starting in 2000, so it's going to go over the last 2 decades. And there are 25 events that we've recorded where meteors have actually impacted the Earth. Now, some are bits of comets, others are asteroids that actually hit the Earth's atmosphere and exploded, or actually hit the ground. There was a major event that just happened in Russia a couple years ago in Chelyabinsk. It was called an airburst. It actually exploded about 50 miles up above the Earth's surface. That explosion created an airburst that went down to the surface and broke windows. There was about 1,000 people that were pushed backwards and injured from that. Of course, the famous one in Siberia in 1908, an airburst that actually flattened about 100 square miles in the thick Siberian forest. We think it might have been a piece of a comet that exploded around about the same height, maybe a little bit lower in the Earth's atmosphere. But here you can see some of these events. Again, they're kind of all over. Some over 20 kilotons when it hit the Earth's atmosphere. So whenever you would see this, you would see a fireball. You would hear not only a sonic boom, you actually might get one of those airbursts. Of course, I'm going to put up some of these potentially hazardous asteroids here. We talked about that last week. I just want to end with this to kind of show you how many there really are in orbit around the sun. So you're going to see a bunch of little dots up here. I'm going to stop it from rotating. And we'll zoom out just a little bit. Again, these are, there's about over 2,000 now that could potentially hit the Earth. Again, these are just the asteroids, not to mention any pieces of the comet that come flying in. We think the object actually, so researchers came out, the asteroid or comet that hit the around 65 million years, hit Chicxulub crater, came in at the most direct impact, which means it was the highest speed possible, creating the most damage. Something like that was roughly 6 miles across. So think of a comet 6 miles across slamming in the Earth. Considering what a 100-foot mile or 100-foot diameter rock caused a meteor crater, 6 mile created devastation on a global scale. And there are objects out there like, for instance, if Comet 67P, which is not on a collision course at all with the Earth, but if it were to hit the Earth, it would cause another global catastrophe, right? So what are the chances of the Earth getting hit again? Well, in our lifetime, slim to none, right? I mean, we're talking every couple million years or tens of millions of years, the Earth gets hit on a global scale. Of course, the Earth does get hit by smaller objects every single day. And just kind of taking a look at some of these impacts, like on the moon, and just kind of show you how much the moon and Earth actually get hit daily. You're talking tens of objects daily. Most in our Earth, actually, luckily we have an atmosphere. It burns up in the atmosphere. We never see it hit the ground. The moon's not so lucky. It doesn't have an atmosphere. So things hit constantly, creating new craters. And you can see the older crater and younger crater, kind of the difference. Younger crater has material kind of spread around it. So let's actually take a look with one of our new spacecraft actually orbiting the moon. We can actually take a look at younger material on the surface. And so all the kind of red colors that you see are actually some of the younger material on the moon. So these are kind of newer craters, if you will. And just kind of shows in the last 250 million years, we've actually had an uptick in collisions. So younger than 290 million years are all those green dots. So early on, there were much bigger craters that formed, kind of bigger objects. Now, in our most recent history, a lot of smaller objects have been hitting the moon. So there's a lot smaller debris left over. The bigger stuff kind of has already been used up. So a lot of smaller debris actually still hitting the moon and the Earth. So then you can see some of those craters there. All right, I want to end, well, actually, a couple of things. One, just to kind of show the impact of airbursts. So we actually have found footage of the Russian meteor, and I turned off the sound because otherwise it's going to be way too loud. And most of it's in Russian. But here you can actually see some of these footage. Most of the Russian cars actually have cameras in the car. But that's what it looked like. And so when it exploded there, again, about 50 miles up, it did create that airburst. So that is the rock actually coming in. And this one actually, there was a huge sonic boom. You can see it shaking. It actually shattered out that building and many of the windows. And you'll see some other footage here of people being thrown inside the buildings themselves and windows being knocked out. Just pure power. Now, this rock was only a few meters across. Here you can see some other footage. Look to the right of your screen. So there it is coming in to the right and kind of exploding. So almost any given night, if you look up, you'll definitely see some shooting stars. Check out for some bolides. There's some really cool objects as they come flying across like this. Of course, this one made it much lower in the atmosphere, but you might see them kind of explode up. Those were about the size of a softball. This was about the size of our dome. It was about 10 meters across, this particular rock that came in. So, the Earth does get hit, but it's not as much as you think. And, the night sky still is very beautiful, and you can actually see some really amazing things. So I challenge you to go out. It looks like it actually is going to be clear over the next couple of nights. I'll end with that one there. So thank you very much for listening on this fine Friday evening. I hope you guys enjoy the rest of your weekend. Make sure you go out and look up because it is going to be clear. Look for Mercury now in the west. You got Venus is going to be joining Jupiter and Saturn and Mars in the morning sky, along with that comet Swan. With a pair of binoculars, look for the star of Fomalhaut. It's very close to Fomalhaut right now, but of course over the next couple of nights. So next week will be our last virtual Sky Talk for about a month. We'll start again the second week of July. But next week we're going to go back to nighttime sky and just kind of point out some constellations because the sky has moved a little bit. And we're going to show you kind of what you can see here in the nighttime sky at the end of June. So again, thank you and have a great evening. Hope you guys enjoy it. Thank you again. Hope for clear skies. Oh, and someone asked about the dog names. Not quite. It's Neo, Pumpkin, and Olive. So not quite astronomy names, but yeah. All right. So again, thank you and have a great night, everyone.